picture this for a second. Engineer A is rushing to deploy a really critical security patch to your production database. But right at that exact same moment, Engineer B, who's sitting halfway across the world, pushes a configuration update to that very same cluster. So what happens when those two engineers try to update your infrastructure simultaneously? Well, without the right safeguards in place, the answer is just total, unmitigated chaos. We're talking overwritten resources, accidentally deleted networks, and some seriously massive downtime. But thankfully, there is a safeguard. There's a single source of truth that completely prevents this kind of disaster. And honestly, really understanding it is the absolute secret to infrastructure mastery. Hey everyone, and welcome to this explainer. I am so incredibly pumped to guide you through today's topic. We are zeroing in on Terraform state management best practices, specifically geared toward DevOps teams and infrastructure engineers. We're going to take you all the way from beginner concepts straight through to pro-level execution. Because, let's face it, this is fundamentally the most critical component of infrastructure as code. By the time we wrap up here, you are going to know exactly how to protect, manage, and scale your deployments with absolute confidence. Let's dive in. Here's our quick roadmap for today. We'll start with Section 1, what is Terraform state? Then Section 2, dangers of local state. Section 3, remote backends and locking. Section 4 covers isolating to limit blast radius. Section 5 is manipulating state safely. And finally, Section 6, the future of state. All right, kicking things off with Section 1, what actually is Terraform state? To really master infrastructure as code, we have to stop and ask a basic question. What actually connects our written code to the real world? I mean, you write the configuration files, sure, but how does the tool actually know what already exists in your cloud environment versus what still needs to be built? Well, whenever you run an apply command, Terraform generates a file which is usually named terraform.tf_state. And this is basically just a JSON-formatted file whose entire job is to act as a map. It maps the resources you defined in your code directly to the actual real-world infrastructure running out there in AWS, Azure, or wherever it is you're deploying. It tracks the resource attributes, the metadata, the dependencies, all of it. Think about it. Without this snapshot, Terraform wouldn't have any memory at all. It wouldn't be able to track things, detect changes, or plan updates. It would literally just try to blindly recreate everything from scratch every single time. So the huge takeaway here is this. You absolutely must treat your state file like the keys to the kingdom. Since it's an exact, precise mapping of your real-world setup, it inherently contains some incredibly sensitive data. For example, if you're generating a database password dynamically during a deployment, that password is going to be sitting right there in this JSON file in plain text. It is the ultimate definitive record of your infrastructure, which makes it a wildly high-stakes asset that you need to aggressively protect. Which leads us perfectly into Section 2, the dangers of local state. Now, when you're first starting out, it is so tempting to just save your state file directly onto your laptop. It's easy, right? But ask yourself, have you ever actually struggled with a lost or corrupted state file on your local machine? It is an absolute nightmare. First off, all those plain text secrets we just talked about, they're sitting totally exposed right on your local disk. Second, it's just highly uncollaborative. If you and a teammate need to work on the exact same project, how are you sharing that state? Are you going to email a JSON file back and forth? Please don't do that. It's a massive recipe for disaster. Third, it completely forces you into this highly manual workflow where you're just tied to running commands straight from your terminal, completely bypassing any modern CI/CD pipelines. And finally, there's the very real risk of accidental deletion. If your laptop's hard drive crashes, your source of truth is just gone. Poof. The infrastructure as code experts over at Spacelift have a very simple, non-negotiable rule for this. They say you should store your state files remotely, not on your local machine. Simple as that. This is the exact turning point where we graduate from the beginner stuff and really start leveling up to a professional workflow. So let's get into how we do that with Section 3, remote backends and state locking. To actually get that risky local file off of our laptops, we migrated over to a highly available remote backend. We're talking things like Amazon S3, Google Cloud Storage, or a fully managed platform like Spacelift or Terraform Cloud. And doing this is exactly what solves that cold open question we talked about with the two engineers. Because when you store your state remotely, you can turn on something called state locking. So say you're using AWS S3 to store the file. You would pair that with an Amazon DynamoDB table. State locking basically leverages the atomic guarantees of that database to ensure that if engineer A triggers a deployment, that state file gets completely locked down.
If engineer B comes along and tries to deploy at the exact same time, their command gets firmly rejected until engineer A is totally finished. It literally stops concurrent applies from corrupting your infrastructure right in its tracks.
But wait a second, this actually introduces a pretty funny chicken and egg problem. If our goal is to provision all our infrastructure using code, how on earth do we use Terraform to provision the actual S3 bucket and DynamoDB table that are going to hold its own state? Well, here is the bootstrapping workflow you use to solve it. Step 1. You just create your local configuration normally without specifying any remote backend. Step 2. Define those S3 and DynamoDB resources right in your code. Step 3. Run your apply command locally so those resources actually get created up in the cloud and get recorded in your local state. Step 4, now you add the remote backend block to your code, pointing it at those newly created resources. And finally, step 5, run the Terraform and init command. The system is super smart. It'll recognize that new backend and automatically ask if you want to migrate your local state up into the secure remote bucket. Once you get the hang of it, it's an incredibly satisfying workflow.
Moving right along to section 4, isolating to limit your blast radius.
Okay, so now your state is secure, it's remote, and it's locked. The next cardinal rule you have to follow is this. You must absolutely never cram all of your infrastructure into one giant massive state file. You basically have two main strategies for separating out your environments, like dev, staging, and production. Option 1 is using workspaces. They are built right in and super easy to set up, but the catch is they share a single remote backend, which actually makes it pretty tough to isolate permissions properly. Option 2 is using directory structures. With this approach, you create completely separate folders for dev and prod, which results in totally separate state files. Now, yes, this does create slightly more code duplication, but it gives you highly visible, incredibly secure isolation. In fact, experts generally prefer directory structures for this exact reason. Think about it. If you make a massive, terrible mistake in your dev folder, the blast radius is strictly contained to dev. Your production state file doesn't even know what happened. Next up, Section 5. Manipulating state safely. Look, even if you have all these best practices locked in, there are just going to be moments when reality drifts away from your code, or you need to refactor some resources, but you definitely can't afford to tear down the entire production environment. When that happens, knowing your safe CLI commands is crucial. You can use Terraform State List to see everything hanging out inside your state, or State Show to really inspect one specific resource. You've got State MV to move items around, and State RM to remove something from your state file without actually deleting the real-world infrastructure, which is amazing if you just want to stop managing a resource via code. And then there's the import command, which lets you grab existing manually created cloud resources and bring them under your code's control. But listen carefully. Modifying state directly from the command line is strictly break glass in case of emergency territory. In a true pro environment, you always want to rely on config-driven state changes, so everything is fully reviewable in your pull requests.
And finally, we arrive at Section 6, the future of state. The infrastructure as code landscape is moving incredibly fast right now. As we look ahead to 2026, let's impartially break down the trajectories of the two massive engines running this space. On one hand, you have HashiCorp Terraform versions 1.11 and 1.12. They're pivoting hard toward a deeply AI-native ecosystem. They're rolling out things like Project Infograph and Stacks to let you manage insanely complex environments as a single unit. Plus, they're integrating the Model Context Protocol so AI agents can actually understand your entire infrastructure graph. On the other hand, you have the open source alternative, OpenTofu, specifically version 1.11 and up. They are focusing incredibly heavily on security and community orchestration. A huge feature they famously introduced is native client-side AES-GCM state encryption. What that actually means is your state file gets completely encrypted before it ever even leaves your machine. So even if your remote storage bucket gets fully compromised by a bad actor, the state file itself is completely unreadable without your specific local decryption key. Honestly, both of these paths are offering some truly incredible pro-level advancements for managing state at scale.
All of which brings us to the end of our explainer and leaves you with one vital, final question to think about today. Is your state file currently acting as a single point of failure, or is it your absolute strongest asset? We've walked through just how sensitive this file is, the dangers of keeping it local, the rock-solid security of remote backends and locking, how directory structures isolate your blast radius, and the safest ways to manipulate resources. I really urge you to take a hard look at your own infrastructure setup today. Start applying these pro-level practices, get that state file securely locked remotely, and make absolutely sure your infrastructure is resilient, secure, and ready for whatever deployments come your way next. Thanks for joining me.